In the first animation, we discussed how neurons communicate with each other and presented some of the differences between action potentials and postsynaptic potentials. In this video, we will discuss how these properties of postsynaptic potentials generate dipoles. Dipoles are defined as a separation of charge over distance and are fundamental to measuring and recording activity using EEG. Postsynaptic potentials do more than merely excite or inhibit a neuron. An excitatory postsynaptic potential, EPSP, increases the likelihood that a neuron will fire, since it is depolarizing. Or in other words, it lets positive ions flow into the cell. Alternatively, an inhibitory postsynaptic potential, IPSP, decreases the likelihood that a neuron will fire, hyperpolarizing the cell by making the membrane potential more negative. Despite whether they lead to an action potential or not, both EPSPs and IPSPs generate a separation of charge, known as a dipole. Although we have been looking at a generic neuron, EEG signals are primarily generated from a type of neuron called pyramidal neurons in the cortex. Let's walk through the EPSP here and how it creates a dipole in a pyramidal neuron. When the postsynaptic neuron receives an excitatory signal from an active axon terminal, positive ions flow into the dendrites. You can see that the intracellular space becomes more positive, rendering the extracellular space relatively more negative at the reception site. The extracellular space at the opposite end of the postsynaptic neuron is now relatively more positive compared to the extracellular space at the reception site. This pair of equal and oppositely charged poles, spanning across the distance between the dendrites and cell body, become the conduction medium for a dipole. The current flows from the positive site, source, and into the negative reception site, sink. An IPSP creates a dipole in a similar manner, but the polarity of the dipole is reversed. By understanding how dipoles are generated, we can begin to understand how EEG works.